You know, if you think about the different species of aquatic invertebrates that live in lakes versus those that live in rivers and streams, they tend to be very different. But when it comes to the drivers of trout feeding behavior, the same basic principles apply to both ecosystems. Of course, there are differences in the way trout adapt their approach to foraging, but those core cognitive processes that lead to prey recognition and selection, they're very much the same. The concepts I'll be covering throughout this series are equally applicable, whether you're into fishing lakes or rivers and streams. In the last episode of the Entomology Files, we looked at optimal foraging theory, the idea that trout are genetically hardwired to feed as efficiently as possible. But if that's true, why does a trout sometimes eat almost anything that looks edible, and other times refuses fly after fly, even when those flies may look close to what's actually hatching? If trout are trying to feed efficiently, why don't they just eat consistently? Well, the answer is this. As feeding conditions change, as available food resources increase or decrease, the most efficient approach to feeding also changes. Sometimes day by day, sometimes even hour by hour. These different approaches to feeding are what I refer to as feeding modes. And as you'll see, they explain a lot when it comes to fussy trout. These trout feeding modes exist on a continuum, a sliding scale. And at any given moment, a trout's basic approach to feeding lies somewhere along this spectrum. On one end of the scale, trout are highly opportunistic. On the other end, they're extremely selective. But most of the time, they're somewhere in between. The key idea here is this. Trout are not locked into a single feeding mode. Their feeding behavior shifts, depending on food availability, angling pressure, and recent feeding experience. At the far left of the continuum is opportunistic feeding. In this feeding mode, a trout will sample anything that appears even remotely edible. You'll encounter this feeding mode most often in waters with almost no fishing pressure or limited food availability. When food is scarce, it makes sense from an optimal foraging perspective to take whatever you can get. Rejecting potential food items when they're in limited supply, that carries the cost of missed opportunity. Under these conditions, sampling broadly is the most efficient way to survive. And as we saw in episode 2, optimal foraging is all about feeding in the most efficient way possible. If you've ever fished a remote and rarely fished stream or lake, and had fish take just about every fly you threw at them, you're probably fishing to opportunistic trout. On a probability curve, and this is really important, most flies have a reasonably high probability of a take. In fact, the probability curve isn't much of a curve at all. It's almost flat. Under these conditions, the trout standards are low, and they feel safe enough to sample and sometimes spit out any edible looking bits they come across. Slide slightly along the continuum, and we arrive at what I call semi-opportunistic feeding. Here, trout are still willing to sample different food items, but there's a definite bias starting to develop. They tend to favor the food items that are more commonly encountered, food items that they have at least some familiarity with. You'll often see this in waters with low to moderate fishing pressure and low to moderate food availability. Here, trout are beginning to narrow their focus, but not too dramatically. On our probability curve, a slight peak starts to form. Certain flies now lie closer to the top of the distribution, being more likely to be taken, while others begin sliding down the slope. As we move into the middle of the feeding mode continuum, we arrive at what I believe is the most common feeding mode of all. I call this the non-hatch mode. I originally wrote about this concept in a Fly Fusion magazine article titled Matching the Non-Hatch back in 2015. Non-hatch mode is common on trout waters that are fished regularly and have healthy insect populations. And importantly, it's the default feeding mode whenever insects are not actively hatching. Here's how it works. In order to more easily recognize items in the water column as food, trout form what are known as search images for the insects they encounter most frequently. These insects might be the most abundant organisms in the drift, or insects from a recent hatch, or bugs they encounter more often while foraging. You can think of a search image as a mental picture of what's safe to eat. These search images are retained in a trout's memory for hours, or sometimes even days. And most importantly, they strongly influence what a trout recognizes and instinctively accepts as food, even when there's no visible hatch occurring. That's really the key idea. Even when nothing obvious is happening at the surface, trout are not feeding randomly. They're feeding according to recently reinforced expectations. On the probability curve, the peak becomes more pronounced. Flies that resemble recently and more commonly encountered insects lie near the top. Flies that don't resemble them slide towards the tails and are viewed with increased suspicion. This is why generic patterns like a pheasant tail or an Adams may still work in non-hatch mode, but unless they closely match what trout are currently feeding on, they don't always sit near the top of the probability curve. They often lie somewhere down the slope. Next, we move into a feeding mode that most anglers are familiar with, selective feeding. This occurs anytime there's an active insect hatch. Here, trout key in on one or more specific stages of the hatch. Nymphs or pupa rising to the surface, emergers caught in the surface film, maybe adult duns drifting on the surface, or even spent spinners on the water. In this situation, food abundance increases dramatically, and trout can get overwhelmed. Feeding efficiently now means something entirely different. Instead of maintaining the option to sample broadly, it becomes more efficient to lock in on a specific, abundant, and predictable food source. In this situation, the probability curve narrows and the peak rises. Only flies that closely match what is being consumed sit near the top. Everything else drops sharply down the slope, having a much lower probability of being accepted. This is where many anglers begin to struggle. At the far right end of the continuum lies hyper-selective feeding. Here, trout may key in on a very specific subset of the hatch. For example, only nymphs rising within 6 inches of the surface, or only crippled emergers laying on their side, or perhaps only adult duns waiting to take flight. This often occurs during very heavy hatches, or on heavily pressured waters, or both. When the drift is crowded with natural insects or artificial flies, trout benefit from automating their decisions. Instead of evaluating every drifting object from scratch, they filter aggressively, using a very specific search image. Here, the probability curve becomes very steep and narrow. One small region of high acceptance, everything else, nearly zero. But there's another layer to this, one related to what we talked about back in episode 1. You see, at any given time, not all trout are in the exact same feeding mode. If you were to map the feeding modes of all trout in a river or lake, or even a single run, you'd likely see something resembling a normal distribution. During a hatch, for example, most fish might be in the selective zone, but some fish might still be feeding in non-hatch mode, and a few fish may even be hyper-selective. Same feeding conditions, slightly different feeding behaviors. So what's actually happening when you drift a fly over a selective fish that doesn't match what they're feeding on, and it takes your fly anyways? In this situation, you drift your fly repeatedly past the same trout. It ignores it, it ignores it, it ignores it again. Maybe 30, 40, 100 times, more if you have the patience. And then suddenly, it eats it. So what's changed? Likely nothing. you've simply run into the low probability tail of its feeding distribution. Even low probability events occur eventually. From this episode forward, we're going to focus on a key concept, the probability of fly acceptance, or the likelihood that a trout will actually take your fly. Every fly that you tie on occupies a position somewhere on that probability curve. If it closely matches what trout are feeding on, or have recently been feeding on, it sits near the peak. That means a higher probability of a take. Fewer casts required to get a hookup, more fish in the net. If it's a poor match, it lies far out on the tail with a very low probability of a take. That means more time just spent casting and very few fish caught. This reframes fly selection entirely. You're not asking, will this fly catch a fish? Because as we know, any fly will catch a fish eventually. What you're really asking is, where does this fly lie on the probability curve? And your job as an angler, assuming you want to catch more trout, is to move your fly selection as close to the peak as possible. So now we come full circle, back to optimal foraging theory. Why does the feeding mode tighten as food abundance and angling pressure increase? It's because decision making has a cost. Evaluating every drifting object takes time. Figuring out what's safe to eat and what isn't, that requires brain power. See, when food is scarce and angling pressure is low, sampling broadly is the most efficient way to approach feeding. But when food is abundant or risk is elevated, automating the process becomes the safest and most efficient way to feed. Locking in on a specific food type requires less thinking. It reduces cognitive load, and it reduces risk. Efficiency in this context is not just about calories, it's about decision simplification. And that simplification requires recognition filters. Which brings us to the next question. How does a trout create those recognition filters? How does it lock in? How does it recognize one object as food and instantly ignore others? The answer to this lies in a concept we touched on earlier, the search image. Search image is the cognitive mechanism that allows trout to automate their feeding decisions. It's really the engine that drives that sliding along the feeding mode continuum. And that's where we're headed in the next episode of the Entomology Files. Thanks for watching. We'll see you in the next one.